So Earth Explorers are ESA's scientific mission component. These are missions that measure or that are built to answer scientific questions that have so far not been answered. And for this, they carry often instruments that have been built for the first time and that are flown in space for the first time to measure things that no other satellite has seen before. They're often pioneering missions, so many of these missions are then continued or evolved to operational mission concepts that we know from the Copernicus or meteorological programs. In the role of a mission manager, I have the mission authority. I'm overall responsible for the mission, but this does not mean I'm working alone. I have a whole team. So we have people, for example, in flight operations that make sure the satellite navigates through space. We have ground segment people that make sure that the data recorded by the satellite flows down to the Earth and is then processed and disseminated to our users. We have system engineers, instrument engineers, and in-house scientists making sure we meet the data quality requirements that are given by us from the scientific community. And beside this, of course, we also work very closely with our communities, with the scientists outside ESA, but also with operational entities like meteorological forecasting centers, for example. My role is to keep this family together and to make sure we deliver the data that can finally be used by our user communities. So SMOS is a scientific mission, so the main user community is, of course, the science community. And this beauty of the SMOS mission is the diversity of the mission. So we have oceanographers looking at salinity over the ocean. They investigate high wind speeds for predicting hurricanes. Over land, the data is used to understand how soil moisture, for example, changes weather or droughts and floods. It's used in the Arctic oceans to measure sea ice thickness, or over land to measure, for example, freeze-thaw cycles of the soils. Beside the pure scientific use, we also recently witnessed that many of these early scientific discoveries evolved to more operational use cases, and that operational centers pick up this data and use it for their purpose. For example, numerical weather prediction centers use them to improve the weather forecasts or the hurricane warnings. Last but not least, SMOS is a mission that is flying since 14 years, and we have this very unique data record that is now also picked up by the climate community, who uses this as an observational evidence, and so SMOS is contributing to reports like the IPCC climate report. One of the biggest challenges, but also one of the most rewarding aspects of an Earth Explorer mission, is that we only know how the mission works when it is up in space and delivering the first data. So there's a lot of uncertainties often and a lot of unknowns that we have to address when we see the first data flowing in, which is often a challenge for the teams working on it. Just to give you an example, SMOS has a highly sensitive instrument, and that works in a protected frequency band. But despite this band being protected and reserved for scientific use, there is a lot of instruments on the ground, electrical instruments, that cause noise in our signals that we measure with the satellite, and that we need to clean up. This was something we discovered only in the early days, or at least the magnitude of the problem we got only aware when the mission was launched and we saw the first data. And the teams that were working at that time on the mission had to work quite hard to make sure the data flows in the quality that scientists can make use of it. Another challenge, and also another very rewarding aspect of the SMOS mission, is its diversity. So we have people working over the ocean, over the land, over the cryosphere, and most recently even on space weather applications. We have to make sure that all the people get the data. They all come with different requirements and needs, but we want to make sure that everyone gets the best out of this mission, which is on one hand sometimes challenging, but it's also very rewarding to see these different ideas and different use cases. Even after 14 years, we still keep discovering new things. For example, the latest discovery is that we can observe the sun, and we can retrieve information about the sun's activity from SMOS data.